Ready to go. Okay, so I'm Zack W0ZC, and apparently I'm ready now. So 15 years I've been developing a product called Arduino Track, and so I wanted to talk to you guys a little bit about Arduinos in general, and then talk to you a little bit specifically about using Arduinos in your space. So just a real quick show of hands, who has flown an Arduino with some sort of experiment? Several of you. How many of you have used an Arduino in some capacity, tinkering? You know what it is? Okay, good. All right. In that case, I will not spend a whole lot of time talking about the basics, but I'm just going to kind of cover a few little housekeeping things about the Arduinos in general, just for anybody that hasn't experienced it. So the Arduino, it's open source. It's open source hardware and software, and it has several draws to it. One of the draws is it's easily programmed on any kind of special equipment. For any of you that have done microprocessor design over the years, used to be have EEPROM programmers, EEPROM erasers, and specialized compilers, and then of course they got Flash, and that made it a little bit easier. But then a lot of times you have $70 PSOC programmer cords and things like that. And the Chinese got involved, abstract everything out into generics and put it on eBay for 39 cents. But anyway, that's been Arduino's claim to fame. The Arduino Uno is pretty much considered the entry-level option. It's running a 16 megahertz processor. It has a 32K of RAM, or a flash ROM. Half K is used for bootloader. But it does have 2K of SRAM and some EEPROM on board. It has a fair amount of I/O ports, and this is a photo of an Uno. It has a USB connector for programming, and these are all your I/O ports. And you'll notice they're kind of female headers, so it makes it very easy to prototype these things. If you're going to go off to a breadboard, you can stick a little jumper wire in here, come off to a breadboard or whatever experiment you want. And then a socketed chip. It does have a very simple, typically they run at 5 volts. There are some 3.3 volt versions out there. Typically they run at 5 volts, and they have a small regulator on board. I mentioned earlier one of the claims to fame was it was simple, but I think probably the bigger thing that they did, and they almost got this right, was they designed them on stackable. They designed them to be stackable, and there was an early design issue where they weren't exactly on 0.1 inch spacing, which has been, if anyone of you has used it, you pulled your hair out. You can't quite take just a standard breadboard and stack it on here because I forget which side's which, but one of these doesn't quite 0.1 inch spacing, so they don't fit without doing some surgery to your breadboard. So I think that was a horrible mistake. I think they should have fixed it early on in the run, but they didn't, and it kind of became their thing. So the Stackable Shields, there's all sorts of them out here. I put together a list. I brought a few with me even. They have Wi-Fi, data logging. Here I brought along it's actually a touchscreen 3-inch display that if you want to have a user interface that has an SD slot on it, you can plug things in, put graphic resources. Here's a GSM board. If you want a cell phone, there's a SIM slot on the back side. You slap some sort of a SIM card on it, and you can talk. There's all sorts of things: GPS receivers, servo and motor controllers, just plain prototyping that have the 0.1 inch spacing fixed. RF transmitters, and of course the shameless plug for the Arduino Track. So, they can be stacked, and this was the most extreme case I could find on Google quickly the other day, but they are designed to be stacked. So typically you'll have a pair of long leaded plugs, and so you have a female header, and then you have the males going down the bottom. And so you have your Arduino, and you have your various shields, and you can stack them until you run out of pins. Talking just a little bit about the programming environment. It's programmed in a specially designed IDE, Integrated Development Environment. That has become a little bit of a, it's gotten fragmented, to say the least. The Arduino got the Arduino name itself. They got some lawyers involved, and now there's actually 2 Arduino companies, and they're both named Arduino. It's very confusing. And then of course other people have built some plugins for things like Visual Studio, so you can program these things in Visual Studio, which is just further fragmented the market. Unfortunately, I think this is going to be kind of the death of them, you know, as it plays out, but that's where it's at. But they do have an integrated environment, integrated programming, and it uses a USB cable to program. This is just a screenshot of the environment. It's very ugly. This is the original Arduino.cc, I believe, is the website that this comes from. There's also an Arduino.org, which is kind of similar. They seem to be kind of taking off, but this is the environment. Simple tab. You have your source code. You have your program button up here, and then you have your typical file save. There's an integrated serial interface, so if you need to debug things like that, it's all in a fairly nice environment. It's based on Java, but it's packaged up in MSI files, so fairly easy to install. It's cross-platform. It has a lot of stuff going for it. Like I said, if we program via USB, there's a bootloader that has to be installed, and that bootloader is flashed onto the firmware, onto the flash of the Arduino, or actually the Atmel processor. And what that does is basically for the first, I don't know, about 2 seconds when the thing boots up, it sits and waits for a command, and once you plug a USB cable in, it commemorates an RS-232 port, and you hit the program, it reboots the Arduino, and then it loads your firmware. So it's really slick. It's very simple for schools. There's nothing really to teach. There's no cables really getting messed up. It's very simple for schools to get going. And it's just, like I said, it's running over a serial protocol. So this is the basic fundamentals of an Arduino. You've got your setup division, which basically it comes in here, it runs setup, which defines any kind of global variables, sets up any, initializes any sensors, anything like that, and then the loops. It's here and spins like this indefinitely. It's an infinite loop. You can't get out of it, I don't think, because I've never tried, but you can. Next. So this is the probably most simple. This is Blink. If any of you have ever tried to do Hello World, this is the equivalent in Arduino. You initialize an output for a pin. Pin 13 is going to be an output, and then it does that once, and then it loops through here. It turns it on, it waits a second, turns it off, waits a second. All right? So now that's kind of the basics, and you can plug in pretty much any kind of a sensor you want. Like I said earlier, there's SPI, I2C, serial, all these sorts of things. So an I2C sensor is a simple matter of picking off your 2 pins here, picking off power and ground, and you come out, and SparkFun is full of these modules that will plug in very quickly, very easily. Mark mentioned that getting some of your pressure sensors is not as easy as it sounds. Fortunately, one thing that the Arduino does have going for it is they have a lot of libraries that are pre-built. And so while the background, you still do have to go pull your temperature in that, the libraries have simplified it to the point where basically initializing the sensor is just a matter of saying, pressure sensor begin. And so here I'm initializing 2 sensors, an outside air temp and a pressure. Just like Mark was saying, you got to get your temperature, and then once you have your temperature, it passes that in to this pressure object, and then it gets the pressure. And so it is very simple to program this stuff. This is actually a screenshot out of some of the source code for the Arduino track, and we'll get into that here just a little bit. Good. Serial interfacing, basically the same thing. You can pick off, obviously the power and ground, but you can pick off either the hardware serial port, or they have a lot of software serial port libraries, so if you need more than one serial port, it is available using that fairly successfully. Some people have reported problems doing software serial, but I haven't observed it myself, at least at reasonable baud rates, 4800, 9605. This is the code. Many of you have used the U-blocks. This is the source code to initialize U-blocks for high altitude mode. There's it's been a long time since I stole this from somebody, but there's some sort of a setup, something you have to flash out to it. I forget the details, and then you come in here and you send that, and then there's a checksum you have to send. Basically, that builds up an array, and you dump it out through just a GPS. There's a serial dot, or a GPS dot is kind of an abstraction layer that I've written that sends out the serial, and it handles a lot of the decoding of the NEMA strings. So those two strings are basically all it takes to get a U-blocks GPS set up and communicating. TNC is kind of the same thing. Again, I've abstracted out the TNC, basically a KISS type TNC out into an object, but it's kind of the same thing if you want to transmit out to a KISS TNC. It's either serial.write or, in this case, the TNC, basically XNet start and XNet string is what I've been using. Okay. So this kind of concludes just the basic overview of Arduinos. They have a lot of different options. Like I said, there's the Uno, which is a fairly small board, a couple inches by a couple inches. And they have some other, these Pro Minis, they're fairly small. I have a picture on the next slide, but it goes all the way from that, starting at literally a couple dollars up to $50-something, some of these bigger things that have Wi-Fi built in, and Bluetooth, and all sorts of things. Good. So here's just a snapshot of the non-complete family. Again, this is open source, so a lot of people have taken these things and they've developed them out of their own products, specifically the Chinese. But these are pretty much all the genuine Arduino stuff. It was built and it was originally designed in Italy, and so you find the map of Italy on a lot of the more genuine stuff. But as you can see, they've got some very small units out here that are great for, I consider, disposable. I know Bill has a project that I've kind of copied, taking a couple dollar spark fun transmitter at 400 megahertz. You can literally solder it onto the little pins on one of these things, flash it with your call sign, and you can output your call sign being Morse code, which makes a great backup beacon. The Chinese knockoffs I found them on eBay for about $2. A lot of them are free shipping. If you want to take the slow boat from China, and in a couple, 3, 4, 5, 6, 8 weeks, you'll have one of those show up on your door. But I mean, that's disposable level. It just doesn't matter. The Megas, these have a little more processing power and a lot more I/O. And you can see they have kind of a third row of pins here, plus they have a dual row socket back here. There's a lot of I/O. You can do some parallel bits, something like that, but not so disposable, a little more expensive. So, Michael asked me to talk about near-space applications with GPS, or with Arduinos, and so obviously some of the applications that come up are GPS positioning, sensor reading. You can pull in all sorts of different, whether it be pressure, temperature, humidity, light, anything like that. You can pull it in over analog ports, I2C, SPI, serial. You can log out to the SD cards. It's fairly trivial in the Arduino. It's all built-in libraries. You can drive various actuators. You can use that to trigger cameras and do position tracking, or like I mentioned, Bill's little $2 transmitter module. You can do some backup beacon too for, again, considered disposable. Getting specifically more of the APRS stuff, there's two other fairly well-known projects out there. The Trackino, I don't know how you pronounce that. That one, and the micro APRS modem. I looked at these a little bit, and they're not bad products. They've certainly been developed, and people have been using them. The Trackino, Track one. It is a shield. It's designed to run as a, you can kind of see it back here. There's a there's some sort of an Arduino underneath this lighter green shield. And on the shield, they have a GPS module and it looks like a radiometrics transmitter module. And I believe those are voltage regulators in the middle. I've kind of forgotten exactly what you guys do on there, but it's a stackable shield and you can interface out to it and basically push your tones out from the Arduino itself, push them out to pick up some RF and transmit them out to the antenna. The micro APRS, that is, it's basically a KISS TNC. There's nothing really balloon specific or APRS tracking specific. It is designed to plug into a transmitter, whether it be a mobile rig in your vehicle or a Bofang or whatever. But it's designed to just be a TNC, and then you feed it off with some other sort of data source. You got to plug in your GPS. There's no GPS natively built onto it. So those are two projects. They're not bad projects. They've been well developed. They're well documented. I wasn't quite happy with that because I'm kind of the masochist that I am. And so I decided to design this based on a design that I had originally done back in about 2000 based on the PIC processors. And with that, it's basically a complete system on a board, and that's what I've been striving for. Over the years, we've never had any major loss on our balloons, but we've had plenty of frustrations and failures, and usually they come from moving parts, and some of the moving parts weren't necessarily intended to be moved, but they did get moved, such as cables. You have GPS cables that they come loose, or they pull out, the string really fails on them, something like that. And I got tired of fighting with that. The other thing that I kind of unintentionally found was that, and this makes sense looking back on it, but a lot of the random weirdness that we struggled with in a lot of our flights came from long cables. Basically, as those cables get longer and longer, they become less cable and more antenna. And when you have a high RF environment, especially if you're flying 2, 3, 4, 5 watt transmitter for whatever reason, whether it's in your vehicle or on a balloon, when you're flying those higher powers, those wires become antennas and they get back in. They hold the push to talk key lit up, and it won't unkey, and you get RF on your audio signals, and it caused a lot of problems. And I spent many hours hanging. I literally, at our old house, I have the pulleys probably still stuck up on the trees that I would run ropes up through there. And okay, hoist another one up there, we'll let it run for a couple hours and see what crazy stuff this one has. So I developed this Arduino track to become integrated. I didn't want the cables, I didn't want moving parts, I wanted it simple. So this is a picture of the Arduino track, and it has a power supply system. I have a fairly large, beefy 5-volt regulator because a lot of the transmitters run at 5 volts. And so I wouldn't be able to regulate a LiPo or a NiCad or whatever pack down to 5 volts. It does also have a 3-volt regulator on here to run like the U-blocks and the bump 180. And I think that's it on the 3-volt. It has GPS, it's using the U-blocks, GPS, and it has integrated GPS antenna. So there's no need to have an antenna cable plugging in, no those delicate little connectors. The TNC is built basically into this. This is the Arduino, so it's integrated in. It has a transmitter module optionally, or I do have a header here, a 6-pin header, which you can plug in an external transmitter. And I also have the 5-volt and the raw battery voltage going out. So if you want to drive an HT radio off your full power, you can do that. You can also run a lot of them like 5 volts. They run half a watt, maybe a watt off of the 5 volt supply. So you can run those. It does have a voltage divider in here to do battery voltage monitoring, so you can report back where say your battery is. I mentioned the BMP 180 for the temperature and barometric pressure, and I also have a piezo element in here, and I find that extremely helpful. Mark kind of alluded to it. If you plug the thing in, you think everything's good to go, and you go launch the thing, and well, wait a minute, my GPS didn't have a lock because who knows what. And so part of the firmware watches for those situations, and I took it one step further. Rather than just blinking a red LED that someone has to look for and think, this thing actually starts beeping out Morse code. So there's about a dozen different codes that it can do. The one that my crew is painfully aware of is L, so GPS lock. And you plug it in, and for the first maybe a minute if you're lucky, maybe 10 minutes if you're sitting under a metal overhang, and you don't get locked, So that's been invaluable to us. We've actually it's actually saved us from launching one time. We had a GPS lock, and it was a petty little issue. I forget exactly what it was, but it was a petty little issue. But we were able to get that fixed before we released the balloon. It also will tell us the U-blocks have to be initialized, and so for some reason it doesn't initialize correctly, it'll tell us about it. If it doesn't have a GPS signal, like Howard was mentioning that he's using one of these with some of the students, the GPS comes out to these headers, and if you have some other system that's for some reason blocking your GPS because of misconfiguration or something, it'll tell you, hey, not only do I have it blocked, but I don't have a GPS period. So that's we found that to be very valuable. I have not set it up to do any kind of ground-based alerting, although it would be trivial to do. For finding it in the corner wheat fields. It's not overly loud, although my dog would argue with that. She is getting old and hard of hearing, and so she's kind of gotten used to it finally, but she used to go pee whenever the thing would go off. So here's the Arduino track in its two configuration modes. It can be used as a shield, and I have a few customers that are doing it. I fly it that way occasionally, but basically you have an Arduino with whatever. It'll fly with pretty much anything. It just needs about a half dozen or so pins going back and forth. And then the processing happens here, and it basically uses this as a KISS T&C. And you send your KISS commands out to it. The GPS data flows back into the Arduino, so you can pick that up, decode it, do whatever you need to with it. And it serves as a shield. What I found is that most people don't want to do that. I really designed this product to be my own controller board because I'd like to tinker with things. But I started getting a little bit of interest, and what I found was that there's a lot of school groups, especially like middle school and high school, they don't have a lot of technical background, but they want to do something here. And so the Arduino track is designed to also, there's two different modes you can program it as, but it's also designed to be used as a standalone unit. And so you can take and fly this as a standalone unit. There's a battery, a little slot for battery here, and you can fly it out on your flight string. That's all you need to track the balloon. It's configured with a serial cable, and off it goes. It is a complete turnkey solution. The firmware is all pre-written. There's really no reason to monkey with it unless you want to do something special. And there's a Windows-based configuration tool we'll see in a minute. It's very similar to what was the micro something had a little Windows? Tiny Track, yes. It's very similar to that in concept. It's all open source, all the schematics and source code is all published out on GitHub. And of course, I do have a couple of people that have modified it, and so they wanted to write all the stuff out to an SD card. So they had full logs, everything coming from the GPS. I've had some people are using external temperature sensors. It has an onboard, obviously, but that just tells you what's on board. And so you can take that I2C bus, take it out to an external sensor, and get outside air temp. So just real quick, the Arduino track, the configurator tool. It's again just a free download, but real basic stuff: call sign, SSID, the symbol type, your path, and your destination. I do have a feature in there to disable the path over a certain altitude, some meters, MSL. Next. 4 different beaconing modes in it. Simple delay, it just waits about 30 seconds or 45 seconds or whatever. It's not exactly for fairly obvious reasons. It takes a little bit of time to actually send a packet and do all that sort of stuff. Speed-based beaconing. I've got one guy that lugs this thing around on his motorcycle. I'm guessing that's probably what he's using. So when you're putzing around in town, you're making lots of turns typically. So when you're at low speeds, it beacons fairly often. When you're at kind of high speeds, you don't really need so much, and so you can do that based on whatever. Below 10 knots, transmit every 300 seconds. Below 10, 45 knots, transmit every 30 seconds, so on and so forth. Altitude-based beacons is what I usually use. I like to have lots of beacons when I'm on the ground, because if I'm on the way down, it's laying in a field and I'm driving through, I'm not sure exactly where it's at. I want to have the best chance of picking up a beacon if I have to drive past, the little valley or the hill or whatever allows me that opportunity. So I'll typically fly 30 seconds or even 20 seconds on the ground. We don't have a lot of digipeater traffic in Hutchinson. It's not a problem for us. We're glad to have some activity. During the bulk of the flight, I typically slow it down to about 45 seconds and drive my wife's nuts. When's the next packet coming? When's the next packet coming? Well, I'd love to have packets every 15 seconds too, but I'd slow it down to be nice. And then I do have that anxiety when did it burst? Based on GPS, it does detect that it's burst and it'll tell us that. But I still like to have a little more resolution up high, so I'll slow it I'll take that limit down just a little bit. And then of course it has time slots, which I have it configured for tomorrow's activity. Next slide. You can do basic status message. It transmits the burst altitude, so basically every time it queries the GPS, it logs, okay, this is the highest altitude, no, this is the highest altitude, no, this is the highest altitude, well, now we're going down, so that was the highest altitude. So once it bursts, it starts recording what the actual GPS saw. So it's not just, okay, this is the highest packet I got, but it's actually the highest query of the GPS. I transmit GPS fixed quality, battery voltage, air temperature, air pressure. And then when I originally designed this, it was designed to be able to be used with various GPS engines, an old Garmin GPS 18 or 35 or a Telit or whatever. And so you can configure the baud rate and invert the signal line if you want. And when I am around the dog, I'll usually switch it to just blink an LED. And then before the flight, I will turn the LED or piezo on. So like I said, it's a fairly turnkey for the school districts that want to get into this. You need an Arduino track, you need 7.4 volt LiPos work great on it. You need an antenna. And you need a little FTDI or similar programming cable. You need a ham radio license, and I've tried to stress that to them through all the materials on the website that you need a ham radio license. As far as I know, no one's skirting around that rule, although it'd be fairly trivial to do, to be honest. But they seem to get some sort of a sponsor from the local ham radio group, or some schools have their own ham radio license and things like that. But all in all, it comes in about $300, which seems to be well within the range of most school budgets if they have some sort of PTO funding or grant funding. It's, like I said, it's open source. Here's the schematic for it. It's kind of hard to read up here, I know, but basically you have your HX1 transmitter, you have your U-Blox GPS engine, you have, I got a little bit over anal on my filtering on the audio output. It does a PWM output, and I went through the three-phase active filtering, buffering, and I had a really clean audio signal going out. I will say that. Is it necessary? Nah. My next design is going to be probably a single-phase, single-stage filtering, but even that isn't really necessary. And then you have the out processor, and then this is just the headers that go off to the shield, either up or down. You don't have all the I/O pins available because a lot of them are being used by the GPS and things like that. You have a lot of pins that you can't use. The I2C bus is running at 3.3 volts. The SPI port is completely open, and you have the shield headers that you can do whatever. So, taking it further, like I said, one guy, and I can't remember who it was, he may be here today, I can't remember who emailed me about it, but they've logged off the data to an SD card for logging. I've used a temp 102 sensor on that I2C bus and stuck it outside the package. It works really great for getting outside air temp. I haven't written the code to decode APRS, but it's certainly possible. You have a little bit of extra room on there. DTMF data ought to be fairly similar. If you can decode APRS, I think you probably decode DTMF. And then I think someone suggested this morning that I trademark the band, the Balloon Area Network, but I've never developed that. I would like to with an XB or Bluetooth or something. So that's what I've got. Like I said, they're a self-contained unit. One little word of wisdom: don't just fly a rubber ducky antenna. I don't know if any of you have ever done that before, or if you've flown a rubber ducky antenna and you wonder why you can't get any data from your balloon when you're at altitude. It's not because the balloon gods hated you. It's because rubber duckies are designed to have a counterpoise, and it's usually your hand, it's your body. But up at altitude, they get pretty inefficient when they don't do that. You have a quarter wave pushing against nothing, and it doesn't like that. So I found, by experience, if you just tack solder a little 19-inch piece of wire there, you'll be much happier, and so will it. And with that, I think that's all. Does anyone have any questions? Sure.
On the radio chip you're using, it has a back channel capability for radio. Have you tried using that?
On that HX1?
Yeah.
No, I haven't. I wanted the HX1 to be a drop-in replacement for a handheld radio, so I already had to generate all those tones and everything to go into a handheld. So literally the signal just wires off and goes to either that 6-band header or the HX1. So it wasn't really a factor. I am looking at the Chinese chips. Tomorrow I'll be flying one of those, an early prototype of the next version. Mostly because the HX1 is rocked down to 144.39er, and it's not always convenient.
Are you biasing the HX1?
Yeah, I took your advice. The latest PCB, it biases it. All right.
Okay, so that's what we have here, right?
Yes.
And Zach was kind enough to donate this as one of our drawing prizes for today. And so I'm going to let Michael pick a card, and I'm going to let Zach award this. Thank you so much for presenting and for bringing that along. And some luck to you.
Well, the ace of spades.
Oh, it's me.